I'm Stacy with X Factor Technology Hitting Systems. I'm going to talk about angular speed, linear speed, and how they relate to swinging a baseball bat. So let's take a simple demonstration of a bat swing. If I were to hold the bat horizontal to the floor, allow it to swing down and then back to horizontal again, this is a 180-degree swing arc. Now let's say that the bat took 1 second to complete this 180 degrees. This gives the bat an angular speed of 180 degrees per second. Now how does this relate to linear speed or bat speed? To demonstrate this, we're going to need to choose a point somewhere on the bat. So for an example, let's take this point that's about 1 foot below the knob or swing point of the bat. A quick review of basic geometry tells us that the equation for the circumference of a circle is 2 times pi times r. Now pi is simply a number, usually stated as 3.14. For our purposes, we're going to round it to 3. The radius is the distance from the center of the circle to its circumference. In this case, our radius is 1 foot. Now we're not using an entire circle for our swing. We're only using half a circle. So rather than 2 pi r, our equation will simply be pi times r, or 3 times 1, which gives us 3. Now this tells us that as the bat is swung through the 180 degrees, our point on the bat is moving 3 feet. Another way to look at this is if we were to take a string and lay it along the bat arc, and then we were to measure this string, it would measure to a length of 3 feet. Now the question becomes, this linear speed, which is 3 feet per second, does it change according to where we are on the bat? And the answer is yes. So let's pick a second point on the bat and do our calculations again. Now this point is 2 feet from the knob or swing point. Let's do our calculations where pi is 3 times the radius, which is 2, which gives us 6. This means that this point on the bat is moving 6 feet. Its linear speed is 6 feet per second. So a quick review, angular speed of the bat is 180 degrees per second, and it is constant all throughout the bat. Linear speed, however, changes according to where the point is on the bat. So this point right here has a linear speed of 3 feet per second, whereas this point right here has a linear speed of 6 feet per second. And as you can see, this point is moving faster than this point. Now this explains why the broader swing arc is equal to greater batted ball exit velocity due to the bat's sweet spot traveling faster in accordance to the greater distance traveled around the bat arc. Now that I have explained angular speed and linear speed, let's take a look at how bat speed changes with the change in the circumference of the circle.